Good afternoon, class. Here's the chapter about trigonometric functions. Here's section 2, trigonometric functions, unit circle approach. So we covered 5-point angles and their measure, and we're going to go over trigonometric functions, unit circle approach. So we are going to, here's the objectives. We are going to find the exact value of trig functions using a point on a unit circle. We're going to find the exact values of quadrantal angles, exact values of trig functions for pi over 4 or 45 degrees, pi over 6 or 30 degrees, pi over 3 or 60 degrees. Find the exact value of trig functions for integer multiples of those functions. Use a calculator to approximate the value of a trig function. Use a circle of radius r to evaluate trig functions. Those are the objectives. Now, what did we cover? We looked at a vertex, line, and rate. This is what it is. Initial side along the positive side of x-axis, terminal side, counterclockwise rotation is positive. So initial side and terminal side, counterclockwise is positive, clockwise is negative. So clockwise rotation is negative, just reminding you of that. Standard position, the initial side is along the x-axis. So here's the standard position with theta being positive. Here's the standard position with theta being negative. Here's an example of the quadrantal angles as far as the quadrantal angles are along the x or y axis. Right angle, making a 90-degree angle with the initial side, or 1/4 of a revolution, or pi over 2. Straight angle, 1/2 of revolution, 180 degrees, or pi radians. One complete revolution, counterclockwise, gives us 360 degrees, or 2 pi radians. The relationship between the two is that d over 180 is r over pi. If you're given the degrees, put it here and find r. If you're given the radian, put it here and find d, the cross product. So again, as I mentioned, one counterclockwise revolution is 360 degrees or 2 pi radians. 1 degree is 60 minutes. 1 minute is 60 seconds. If you look at this circle, this S is arc length equals r theta, and this area is called the area of a sector, half of r squared theta. It gives rise to an angular speed of theta over t and linear speed of s over t, and of course 2 pi times rpm. If you go with the revolution, remember one revolution is 2 pi radians, and s over t, we can prove that v is r omega. So this is what we have covered. This is the synopsis of everything. Now, 5.2, trig functions, the unit circle. Trigonometric functions, the unit circle. So a circle of radius r centered at 0, 0 has this formula. When r is 1, x squared plus y squared equals 1, we call it the unit circle. Okay. We let t be a real number, and we let p with coordinates x comma y be the point on the unit circle that corresponds to t. This is t units. If you lay it along the curve, the circle, p has coordinates x comma y, s has the length t units. So again, reminding you of the equation of a circle centered at 0, 0, x squared plus y squared equals r squared. In general, with the center at h and k, x minus h quantity squared plus y minus k quantity squared equals r squared, and this is what we showed in the previous page. So definition, x squared plus y squared equals 1. P with coordinates x and comma y Y represents the sine, X represents the cosine. So if you look at this, may make it easy to understand why. This point has coordinates X and Y, and this length is 1 because it's a unit circle. According to the definition, and we're going to discuss that later on again, according to the definition of a cosine, cosine is the adjacent over the hypotenuse. And hypotenuse, of course, is what? 1. So the adjacent, the X becomes cosine, and sine is the opposite over the hypotenuse. Again, the hypotenuse is the same, 1. So the opposite, or the Y coordinate, becomes sine. Very straightforward, everybody. So X comma Y, X is cosine, Y is sine, for a unit circle, of course. Let T be a real number and P with coordinates X comma Y be the point on a unit circle that corresponds to T. The sine function associates with the T, the Y coordinate of the P, and is denoted by sine T equals Y. The cosine function associates with T, the X coordinate of P, and is denoted by cosine T equals X. Again, very straightforward, everybody. If X is not equal to 0, the tangent function associates with T the ratio of the Y coordinate to the X coordinate of P and is denoted by tan T equals Y over X. Of course, as always, the denominator can't be 0. So those are by definition. So tangent is Y over X. In other words, sine over cosine. Cotangent is the reciprocal of that, X over Y or cosine over sine. Again, Y can't be 0. Cosecant is 1 over sine, the reciprocal of sine, and secant is 1 over X or 1 over cosine T, the reciprocal of cosine. So this is the synopsis of all those 6 trigonometric functions. So we have that. Here's the synopsis of what we discussed. Find, example 1, find the exact value of all trigonometric functions if P has coordinates -1/2 and square root of 3/2 is a point on the unit circle. So that's what it is. We just follow the fact that X is the cosine, Y is the sine, first and foremost. So the Y and the X. Sine is Y or square root of 3 over 2, and cosine is X or -1/2. The rest is just the ratio of those, starting with tangent by definition is Y over X, Y over X, or sine over cosine. And I hope you see that it's a complex fraction, the 2 drops minus square root of 3. The rest of them, everybody, are just the reciprocals. The reciprocal of sine is cosecant. The reciprocal of cosine is secant. The reciprocal of tangent is cotangent. That's all. So cosecant is the reciprocal of that, which means 1 over square root of 2 or 2 over square root of 3. I'm going to actually show you that one, making sure okay with that. So this is 2 over square root of 3, the reciprocal. And you multiply by square root of 3. Square root of 3, you get that. This one is 1 over -1/2, gives you -2. This one gives us 1 over negative square root of 3, the reciprocal. We get those. I'm assuming Everybody's comfortable with the concept? All right, we are going to move on, everybody. Find the exact value of the trig functions of quadrantal angles. Starting with theta equal to 0, we know this location is 1, 0. And all we need to know is that x is cosine, y is sine. So cosine of 0 is 1, sine of 0 is 1. And we can figure out the rest accordingly, because tangent is sine over cosine, which makes it 0, and the rest of them are reciprocal. So x comma y, cosine and sine. So first recognize this one, everybody. This comes from the pair. Make a note of that one. Tangent is sine over cosine. Now cotangent is the reciprocal of 0. 1 over 0 is undefined. Cosecant is 1 over sine. 1 over 0 is undefined. Secant is 1 over cosine. 1 over 1 is 1. Now this one, pi over 2 or 90 degrees, coordinates 0, 1. This represents x or cosine. So cosine of pi over 2 is 0. This represents y, or sine of pi over 2 is 1. So again, we want to concentrate on those two. Tangent is sine over cosine. 1 over 0 is undefined. Cotangent is the reciprocal of that, or you can say 0 over 1, which is 0. Cosecant, one over sine, 1. Secant, 1 over cosine, 1 over 0 is undefined. Pi or 180 degrees coordinates -1, 0. So right away, x is -1. That means cosine pi is -1. Y is 0. That means sine pi is 0. And let's concentrate on those two only. So what is tangent? Sine over cosine, 0 over -1 is 0. What is cotangent? The reciprocal of that is undefined. Cosecant, 1 over sine, 1 over 0, undefined. Secant, 1 over cosine, 1 over -1 is -1. Three pi over 2. 3 of pi over 2 coordinates 0, -1. So cosine of 3 pi over 2 or 270 is 0. Sine of 3 pi over 2 or 270 is -1. Again, I want to concentrate on those two. Comes from here. Concentrate on those two. Quadrantal angles. That's how you remember. Now, tangent is the sine over cosine, -1/0 undefined. Cotangent, the reciprocal of that 0, or the cosine over sine. Cosecant, 1/sine. What is 1/1? -1. Now, secant, what is 1/cosine, 1/0? Undefined. UD short for undefined. Let me write that. All right. If theta equals t radians, the 6 trigonometric functions of the angle theta are defined as sine theta is sine t, cosine theta is cosine t, and the rest of it. In other words, theta or t, theta represents the angle, t represents the arc, okay, or arc length. But they can be intertwined. S, t units, theta, t radians, okay? And again, those quadrantal angles, you really don't have to memorize them. Just remember the quadrantal coordinates for each pair. For here, for example, is 1, 0. Here is 0, 1, -1, 0, 0, -1. You have the answer. X is cosine and sine is y. Again, x comma y. X is represented by cosine, y is represented by sine. Find the exact values of the trig functions that are multiples of quadrantal angles. For example, 3 pi. So basically, you go a complete revolution is 2 pi, and then you add half of revolution. So a complete revolution and puts you back. Ultimately, the same result as pi. So you want sine of 3 pi is the same as sine of pi, which is the y coordinate of this pair, which is 0. And in fact, while you're at it, you should recognize quickly cosine must be the same as cosine of pi, -1. Now, cosine of -270 degrees. So now you go 270 degrees or 3 pi over 2 in a negative direction. When you go in a negative direction, it's the same as going in a positive direction, pi over 2. Puts you here with coordinates 0, 1. Cosine is representing the x coordinate, therefore x or 0, just for the sake of argument. If the question asks, what is the sine? Say it's 1 just from the unit circle. So quadrantal angles are very straightforward. There's also a bunch of common arcs. So we want to find the exact values of the trigonometric function pi over 4 or 45 degrees. Here's the methodology. As you can see, this is a unit circle and 45 degrees or y equals x. It's very straightforward that y equals x, or 45 degrees represent the same line, or in this case, the same ray. And so if you're looking at this point, this is 45 degrees. This is on the line y equals x. Therefore, x and y have the same coordinates. And we know x squared plus y squared equals 1. However, because y is equal to x, if I replace the y with x, I get 2x squared equals 1. So y equals x squared and x squared is 1. Of course, we are looking at x and y being positive. So 2x squared equals 1. X squared is 1/2. X is plus minus, but we are in the first quadrant. X is positive. So 1 over square root of 2 or square root of 2 over 2. And please, it's one of those common numbers. You should know 1 over square root of 2 and square root of 2 over 2 are the same. Because if you multiply this one by square root of 2 over square root of 2, you get this one. So you should know that. It's very straightforward. You've seen it before. And so therefore, P has coordinates that are identical, and they are square root of 2 over square or 2 or square root of 2 over 2 for each case. So x is that, which means cosine of 45 degrees is that. Y is that, that means sine of 45 degrees is also the same thing. So now we are going to put those coordinates here. And therefore, we're going to claim sine of 45 degrees or pi over 4 is the same as cosine of pi over 4, which is square root of 2 over 2. They are identical. Now, what is tangent? Sine over cosine, they are identical, becomes 1. What is cotangent? The reciprocal of that, 1 over 1 is 1. Cosecant is 1 over sine. Secant is 1 over cosine. For example, if you look at the reciprocal of this one, it's easy to see. The answer is square root of 2 over 1 over square root of 2. So reciprocal of this, okay, or reciprocal of this, in both cases, square root of 2. We should know that. Normally, when we do know these two, we can figure out the rest, okay? But it's a good practice to memorize all of it. Now we want to find the exact values of trigonometric expressions. Sine 45 times tan of 45. You plug in square root of 2 over 2 here, 1 here, and the product is square root of 2 over 2. Again, I put them here. We should memorize them. It's a must. Secant of pi over 4, which is square root of 2, times cotangent of pi over 4, which is 1. And we get square root of 2. And again, if you don't memorize it, just 1 divided by cosine. 1 divided by cosine. All right, let's do those questions. And sine of 45 times cosine of 180, that would be square root of 2 over 2 here. Negative 1 here. And the product is negative square root of 2 over 2. It's very straightforward, everybody. I hope everybody's fine with that. All right. Tan of pi over 4 is 1. Minus sine of 3 pi over 4 is negative 1. 1 minus -1 makes it +1, and it's 2. Secant of pi over 4 is square root of 2. If you haven't memorized it, 1 over square root of 2 over 2. Okay, so in other words, this is 1. It's a different color. That's what we mean in case. So square root of 2 to the second power. Cosecant pi over 2 is the same as 1 over sine pi over 2. We know sine of pi over 2 is 1. Its reciprocal is also 1. So this gives you 2 plus 1 makes it 3. Again, knowing common trigonometric functions and their values, common arcs, common angles, is a must. Let me remind you of what you have seen before. A triangle is a specific type of polygon having only 3 sides and 3 angles. The angle sum property of a triangle. The sum of all interior angles of a triangle will always add up to 180 degrees or pi radians. Types of triangles with respect to the length of the side. Scaling triangle. All sides and angles have different measures. Isosceles triangle has 2 equal sides and 2 equal angles. Equilateral triangle. All sides and angles are equal, which has to be 60 degrees because 180 divided by 3 makes it 60 degrees. When 2 sides are equal, 2 angles are equal. Types of triangles with respect to the angles. Right angle triangle, one of the 3 interior angles is 90 degrees. Acute angle triangle, all the 3 interior angles are acute, that means less than 90 degrees. Obtuse angle triangle, that means one of the 3 interior angles is an obtuse angle, meaning has a measure greater than 90 degrees. You know, we can't have 2 of them because then it goes beyond 180. So this one is a right triangle. All of these angles less than 90 degrees acute. One of them is larger than 90 obtuse. Just to remind you of those terminologies. Find the exact values of trigonometric functions for pi over 6 or 30 degrees and pi over 3 or 60 degrees. So we start with the right triangle of hypotenuse 1. So this is 30 degrees, this is 60 degrees, and this is 1. One angle is 30 degrees or pi over 6, and the other one is pi over 3 or 60 degrees. Make a second congruent triangle. Make an identical angle, but put it on the right side as follows, meaning this side is identical to this side is the same, and this side is the same as this one. So what is this? Equilateral, because this is 1, and therefore the triangle is equilateral, so all sides are 1, therefore 2a must be 1 and a is 1/2. Why is that? This is 30 and this is 30, that adds up to 60. If this is 60, this has no choice but to be 60. The fact that all angles are 60 degrees, it makes it an equilateral. So we're going to go with the Pythagorean theorem, a squared plus b squared equals c squared. So a squared plus b squared equals c squared. And this is 1. This is 1, so a is 1/2. When you square it, you get 1/4. B is missing. We're going to find it. So if you subtract 1/4 from 1, get 3/4. B squared is 3/4. And B is the square root of 3/4 over square root of 3 over square root of 4, which is 2. So B is square root of 3/2. And so let's put it down. Now we found this side to be 1/2, this side to be square root of 3/2. You can even recall that the concept of opposite over the hypotenuse, for the sine, adjacent over the hypotenuse for the cosine, or you can lay it down along the unit circle to see what happens in the following manner. So we want to find the exact values, for example, for 60 degrees. So the way we put this down here, this is 1, right? That's a unit circle. This is 1/2, right? This is square root of 3/2. Therefore, P has coordinates x comma y, which is 1/2 square root of 3/2. So that makes cosine 1/2. Cosine of 60 degrees is 1/2. But sine of 60 degrees or pi over 3 is square root of 3 over 2. So sine is y, cosine is x, tan is y over x. So sine is square root of 3/2, the y coordinate, and cosine is the x coordinate 1/2. Now, if we divide sine by cosine, it becomes square root of 3. I hope you recognize the two drops from the top and the bottom. And the rest of them are the reciprocals. So we got this from here. Sine is square root of 3/2. So cosecant is 2 over square root of 3. Secant is 2 over 1. And cotangent is 1 over square root of 3. So 2 over square root of 3 you get 2 square root of 3 over 3. Secant is just the reciprocal of 1/2, which is makes it very easy just to. Cotangent is 1 over square root of 3, the reciprocal of that. Rationalize it, and you get square root of 3 over 3. Again, pretty straightforward, everybody. So pi over 3 or 60 degrees, we know, again, as long as we know sine and cosine, we can figure out the rest. Let's do 30 degrees. Again, you already can use the triangle and understand the concept of opposite over the hypotenuse and adjacent over the hypotenuse. Or if you lay it down in this manner, this is 1, this is square root of 3 over 2, this is 1/2, and this one has coordinates square root of 3 over 2 and 1/2. This is 30 degrees. Now, x is the cosine, so cosine of pi over 6 or 30 degrees is square root of 3 over 2, and sine is 1/2. Okay. Sine is 1/2. Cosine of pi over 6 or 30 degrees is square root of 3 over 2. So what about the rest of it? Well, tangent is this one over this one, sine over cosine, 1/2 over square root of 3 over 2, the 2's cancel out, 1 over square root of 3. This is 1 over square root of 3. You multiply the top and the bottom by square root of 3. And you get square root of 3 over 3. Now, the reciprocals are the answer for the rest of them. So for sine, flip it over, 2. That's cosecant. Cosecant of pi over 6 or 30 degrees is 1 over 1/2. The reciprocal is 2. Secant, you flip this over, you get 2 over square root of 3, and again, let me do it. You get 2 square root of 3 over 3 because you have to rationalize. I mean, if you don't, it's not that big of a deal, but understand what happens. And cotangent is the reciprocal of tangent. By the way, 3 over square root of 3, many people know it's square root of 3. If you don't, just rationalize, and you get 3 square root of 3 over 3, which is square root of 3. All right. Example 8, a rain gutter is to be constructed from the metal sheet of width 12 inches by bending up. So here's 12 inches. We bend it up from here and here. 1/3 of the sheet on each side. So that means 4 in the middle, 4 on the right, 4 on the left. We bend it. 1/3 of the sheet on each side through an angle theta. There's some sort of an angle here. Okay, this one, and this one. They're all theta. All right. Prove that the area, this area, just a trapezoid, of the opening, this area is 16 sine theta times cosine theta plus 1. And then find the area of the opening for theta equals 30 degrees, 45 degrees, and 60 degrees. This is not a big deal because you just plug in. Okay, I'm not worried about that. This is the one we want to quickly look at. First and foremost, please understand this is a trapezoid with the area equal to half of the height times b1 plus b2. So this is the case. First and foremost, why is this 4 cosine theta? Because if you look at this angle, okay, is theta. Cosine theta is the adjacent. This distance I'm going to call d over the hypotenuse, which is 4 inches. Therefore, d is 4 cosine theta. So that's a proof. I hope everybody can see that. When we bend this to an angle of theta, this distance is what? 4 cosine theta. This distance remains as 4. And this distance again is 4 cosine theta. So A, the area is half of h times b1 plus b2. This is a trapezoid, everybody. This is a trapezoid, and this is the formula for the trapezoid. So the height is b, which we are going to discuss that in a moment. And the base, the small one is 4, the large one is 4, plus 4 cosine theta, plus 4 cosine theta, or 8 cosine theta, if you will. Okay. Now, what is this height b? Use a different color. Sine theta is b over 4. If you look at this triangle, everybody, sine theta is b over 4, so b is 4 sine theta. So the height is 4 sine theta. B1, the smaller side or base, is 4. B2, the largest one, this side, add up these 3 pieces, which is 4 cosine theta, 4 cosine theta, which makes it 8 cosine theta. So let's plug in. Into this goes A equals 1/2 the h, which is 4 sine theta, and B1 plus B2. So 1/2 and 4, that gives us 2 sine theta. This one is 4 and 4, 8, and this 2 is 8 cosine theta. So again, outside 1/2 times 4, 2 sine theta. Inside 4 and 4 is 8, 4 cosine, that gives us 8 cosine theta. And I hope you see that you can take the 8 out of this one. By writing it as 8 times 1 plus cosine theta multiplied by 2. And believe it or not, this is the proof. That's the main part. The rest is elementary. So we proved that the area is 16 sine theta cosine of theta plus 1. Now, theta is 30 degrees, theta is 45 degrees, theta is 60 degrees. Those are our common arcs. We're going to, find the values, but those are not big deals. Those are very straightforward. So for 30 degrees, we are going to replace the theta with 30 degrees here. We know sine of 30 is 1/2, and cosine of 30 is square root of 3 over 2. This becomes 8. If you multiply it by this, 8 divided by 2 is 4. 4 square root of 3 plus 8. This is an exact answer, everybody. This is an approximation, and the units of the width squared. We go back to this, and now we change the theta to the second one, 45 degrees. And we work on it. We just plug in. And I hope it's clear to everybody. It's really not that big of a deal. 45 degrees, 16 sine of 45 degrees, cosine of 45 degrees plus 1. Sine and cosine are both square root of 2 over 2. The product of these two is 8 square root of 2. And then when you distribute, you get 8 plus 8 square root of 2, which is an exact answer. You plug it in, you get 19.31 inch squared. Again, very straightforward, everybody. We do the same thing with the 60 degrees. And for 60 degrees, sine of 60 degrees square root of 3 over 2, and cosine is 1/2. 16 divided by 2 is 8, so 8 square root of 3 times 1/2 plus 1. Please understand this is 3/2, everybody. So 3/2 times 8 square root of 3 gives us 12 square root of 3. And this is exact answer. Same units, h squared, everybody. Same units of the area. It's important to know it's the same units of the area. Same units of the area. We can't. Anytime you're dealing with a word problem class and units are given, you have to give it back with proper units. All right, we continue. Again, we know x squared plus y squared equals 1. P x comma y, sine is y, cosine is x. And the exact values of the trigonometric functions of integer multiples of power over 4, 45 degrees, power over 6, 30 degrees, and power over 3, 60 degrees. To find that, all you have to do, extend the line, if you will. If you cross a line like this, okay, for the 45 degrees, just notice this square root of 2 over 2, this square root of 2 over 2. This one, both of them become negative, and this angle is 5 pi over 4. Therefore, you have the answer for 5 pi over 4. The same thing here for pi over 6, the same thing here for pi over 3. You just extend the line, and you should be able to figure out what the rest is. Okay, as an example, cosine of 3 pi over 4 is minus square root of 2 over 2, but sine is square root of 2 over 2. And by the way, we will discuss that in the first quadrant, for example. All trigonometric functions are positive, but in the second quadrant, sine is positive. And in the third quadrant, tangent and cotangent, and in the fourth one, cosine is positive. So this is something that will be helpful as far as the answer is concerned. So please pay attention to these lines, which will help us come up with the answer. So basically the same values, but depending on the location, they become positive or negative. For example, in the third quadrant, both of them become negative, okay? Just as an example. So you see that. In the second quadrant, x becomes negative. Therefore, cosine becomes negative. In the fourth quadrant, y becomes negative. Therefore, sine becomes negative. Just remember that. That is helpful. So now, find the exact value of multiples of those angles, pi over 3 and pi over 6. For example, cosine of 150 degrees or 5 pi over 6. Please understand 5 pi over 6 or 130 degrees, 150 degrees are the same. And in this case, cosine, remember it's in the second quadrant. In the second quadrant, cosine is negative, so minus square root of 3 over 2. Again, for now we put them here, but you should be able to memorize them easily. Sine of negative 30 degrees. So this is 30 degrees or pi over 6. This way, would be negative 30 degrees. And sine is the same as y, and therefore it becomes negative. Tan of 4 pi over 3, when we extend this, this is 4 pi over 3, everybody, and over here, both sine and cosine become negative, and because tangent is the ratio of sine to cosine, it remains unchanged, in essence, the same as pi over 3 or square root of 3. So you can divide these two numbers, the ratio of sine to cosine, and you get positive square root of 3. Again, sine and cosine are both negative, but tangent and cotangent are positive. 7 pi over 6. 7 pi over 6 puts us here in this quadrant, the third quadrant. Both sine and cosine are negative, so the same as the sign here, but negative here, so minus 1/2. I will look at this concept from a different point of view in a moment, known as a reference arc. That is helpful, but as long as you know pi over 6, you can figure out any multiple of that and knowing where it lands. Again, first quadrant, everything is positive. Second quadrant, sine is positive. Third quadrant, everything is negative except tangent and cotangent over here. Cosine is positive. By the way, cosine, and that means also secant because it's the reciprocal of that. Use a calculator to approximate value of trigonometric functions. Your calculator has buttons for sine, cosine, and tangent. So to find values of the remaining trigonometric functions, we use the reciprocals. So for example, we want to use a calculator to approximate the value of those values, those because are not common arcs. So you put cosine of 48, gives you the answer. And of course, how many decimals, whatever they ask you. Cosecant, we put 1 over sine. And tan of pi over 12, we use pi, okay? There's a key for that. And it has to, you have to be careful with that. This has to be in degrees. This is in radians. So when you go to the mode, radian must be highlighted, not degrees in this case. And so when you put tan of pi over 12, gives you this. And again, what is the answer? However many decimals. For example, if they said 4, 1, 2, 3, 4, next to it is 4, so the 9 doesn't change, and you're done. Use a circle of radius r to evaluate trigonometric functions. What happens instead of x squared plus y squared equals 1, a unit circle, we use a general case of x squared plus y squared equals r squared. In the case of a unit circle, x and y represent cosine and sine, but if it's x squared plus y squared equals r squared, we have to be a little bit careful in the following manner. When it's r squared, p with coordinates x and y, we're going to call them a and b, okay? Sine, all of them get divided by r in essence. So y, instead of saying sine equals y, we say y over r, or b over r, the second coordinate. Cosine, instead of saying x, is x over r or a over r. The rest of them follow in the same manner. Tangent is still y over x. Because of the ratio, the r goes away. And the rest of them are the reciprocals. So cotangent is the same as tangent, but the reciprocal, a over b. Cosecant, r over y, r over b. Secant, r over a. So as long as we know these two, we really should be able to come up with the rest of them. And it's given here. Needless to say, in all cases, the denominator cannot be 0, everybody. The denominator cannot be 0. So for example, we want to find the exact value of the 6 trigonometric functions of a positive angle theta with coordinates 4, -3 is a point on its terminal side. So it's really a good idea to pinpoint the point. And now it's on x squared plus y squared equals 25. The reason is because you have to figure it out. And the way you figure it out, this has coordinates 4, -3. So you go with x squared plus y squared equals r squared. So probability point with coordinates x and y, or a and b with coordinates 4 and -3. A is 4, b is -3. R is square root of a squared plus b squared. Please pay attention, x squared plus y squared is r squared. So a squared plus b squared. So the coordinates get squared up. So this is 16, this is 9. They add up to 25. Square root of that is 5, and that's why we have it here, 25. Now that we have that, Sine is b over r, so negative 3 over 5. Cosine is a over r, 4 over 5. And tangent is b over a. It really makes no difference. So minus 3 over 4, because both of them have the same denominator. So those are very straightforward, just following the formulas. The rest of them are the reciprocals. So cosecant is minus 5/3. Secant theta is positive 5 over 4. Cotangent theta is negative 4/3. So it's easy to find the rest of them, everybody. Makes sense? Any questions, everybody? Excellent. All right. Example 12. Find the exact value of each expression. Those are multiples of pi over 4 45 degrees. Find the exact value of each expression. Cosine of 135 degrees. Well, if you go with that, 135 degrees, that means 90 plus 45 degrees. That means the second quadrant. That means this location. Okay. 135 degrees or 3 pi over 4. So this is the pair. Cosine is the x coordinate. Minus square root of 2 over 2. At 3 pi over 4 is identical to 135 degrees. We are looking at the same location, but for tangent is sine over cosine. So this number over this number, which gives you negative 1. For 225 degrees, it's 180 plus 45, or 225 or 5 pi over 4. This is the location. And the coordinates are both negative. So what is the sine? What is the cosine? Both of them are minus square root of 2 over 2. In this case, we're interested in sine, of course. Cosine of minus 5 pi over 4. I hope you realize if we go in a negative direction, it's more than pi, right? It's going this way. So it ends up here. So positive 3 pi over 4 and negative 5 pi over 4, they have the same terminal side. One way to know it for this one class, if you add 2 pi, just for the sake of argument, so you see, if you add 2 pi, you end up with 3 pi over 4, and therefore it's the same location as this one. So I hope you see how you find that. So we have those coordinates, and we want cosine, which is the x coordinate. So we want the cosine of that, which is the x coordinate. So it's negative square root of 2 over 2. Now 9 pi over 4, I hope you see that this is 2 pi plus pi over 4. It's the same as pi over 4. And therefore, the answer is square root of 2 over 2. Now, what I want to add at the end is this concept, and that is called reference angle or arc. Class, the easy way is to use the reference angle or arc. They call it theta hat, theta prime, theta bar, depending on the text. Again, they may call it theta hat or theta bar or theta sub r, things like that. It is the reference arc, meaning this angle, please understand that the reference angle is the smallest angle, okay, with the x-axis. For example, this one is pi over 4, right? But if you look at this one, this is the reference arc. For this one, the reference arc, this one, which is 45 degrees. For this one, this is the reference arc, again, 45 degrees. For this one, this is the reference arc. So in the first quadrant, they are identical. In the second quadrant, pi minus theta. So for example, if it's 135 degrees, 180 minus that is 45 degrees. Or this one, pi minus 3 pi over 4 is pi over 4. If it's in the third quadrant, whatever the angle is, minus pi. For example, 5 pi over 4, subtract pi from it gives you pi over 4. It's in the fourth quadrant, 2 pi minus theta. Okay, 2 pi. For example, 7 pi over 4, if you subtract it from pi over 4, gives you 2 pi. It gives you pi over 4. All of them have pi over 4 as a reference arc. What does it mean? All of them, the trigonometric functions have the same value except either positive or negative. And all you need to know the quadrant. So for example, here, so all of them are square root of 2 over 2 sine and cosine. But in this case, on this side, sine is negative, cosine is positive. This third quadrant, both of them negative. Fourth quadrant, cosine negative. So pay attention to this concept, and it makes it very easy to find the exact value of each expression.